Hello there, my name is Z Samo, and this is my final term project. I'll walk you through a full data analysis, visualization, dashboard development, and real-world deployment using the Diabetes 130 US hospital dataset. This project covers everything from exploring visualization all the way to building and deploying a fully interactive analytical dashboard. In healthcare, understanding hospital encounters for diabetes patients is extremely important. It tells why patients are staying longer, why they return, and how clinical decisions affect outcomes. This project focuses on identifying patterns in hospital stays, lab work, medication, demographics, and readmission outcomes. My goal was not only to explore the data but to transform it into a tool that can help hospitals make data-driven decisions. This dataset contains more than 100,000 inpatient encounters between 1999 and 2008. It includes demographics, diagnosis, procedure, medication, and readmission outcomes across the next several slides. We will see how the data is distributed, how groups differ, how clinical variables relate, and where patients and bottlenecks appear. How are we going to interpret these visualizations? As we go through this visualization, I would like you to consider these 4 questions. What do the distributions look like? How do demographics groups compare? How do clinical features relate to each other? Where are the highest density patterns? Each chart is selected to help reveal one important aspect of hospital operations. The 3D scatter plot shows how hospital stay length relates to lab procedures and medication. What we immediately see is that most patients stay under 10 days and fall within moderate clinical activities. The area plot then sums up overall magnitude of features, showing how these hospital activities accumulate across the entire dataset. This group bar chart compares readmission across races and genders. We can see slight variation by gender and more noticeable differences by race. The stacked bar chart shows how different admission types relate to readmission categories. Emergency admission dominates both short-term and 30 days readmissions. For slide 7, box plot and scatter map. The box plot highlights how times in hospital vary across race and gender groups. Most patients stay 3 to 5 days, but there are meaningful outliers. The cluster map then groups correlated variables together, revealing the lab procedure, medications, and hospital days tend to move together. The contour and count plot. The contour plot shows the densest patient distributions, clustering between 3 to 6 hospitals days and around 30 to 50 lab procedures. The count plot shows that there are slightly more female patient encounters than male. Distribution plot and heat map. The distribution plot shows that hospital stay duration is right skewed. Most patients leave quickly with only a small percentage staying long. The heat map highlights correlation between key clinical variables. Strong relationship appear between time in hospital, medication, and lab procedures. Boxing and Hexbin plot. The boxing plot captures the medication count distribution more precisely than the standard box plot, especially Details. The Higgs-Beam plot shows high-density areas where lab procedures and medication overlap, helping us understand clinical workflow intensity. Histogram and KDE and joint plots. The histogram plots several peaks in lab procedure counts, suggesting common clinical patterns. The joint plot measures time in hospital versus lab procedures, with KDE showing where most patients fall. KDE plot and line plot. The KDE plot compares hospital stays among readmissions categories. Patients not readmitted cluster around shorter stays. The line plot shows mean hospital stays by age. Older age groups constantly stay longer. Pair plot and pie plot. The pair plot gives us a multivariant view of major numerical features relate and cluster. The pie plot shows the racial distribution with a large majority being Caucasian, followed by African patients. The QQ plot and regression plot. The QQ plot shows that time in hospital does not follow a normal distribution. Importance when showing statistical tests. The regression plot shows a positive relationship between lab procedures and medication. More procedures generally mean more medication. RAG plots and strip plots. The RAG plot shows raw medical counts. Each line is a patient. The strip plot adds demographic groupings, helping us compare medication usage across race and gender. Violin plot. The violin plot visualizes hospital stay distribution across gender and readmission groups. These shapes shows density differences and where each group is centered. Now we will move to the dashboard. The dashboard uses Python, Panda, NumPy, SciPy, Skitlearn, giving us a full data processing engine. It supports missing, value handling, outlier removal, transformation, summary, stats, and PCA. The app layout is built in Dash and Plotly with a modular structure. The app pie for the server, the dashboard for the UI callbacks, the data processing for cleaning and analytics. Everything updates interactively. How the dashboard works. The user loads and gets an overview. The data processing tab provides cleaning strategies, outlier detection, and transformation. Statistical analysis lets users run normal tests, PCA, and correlations. The visualization builder lets users create any chart. The storytelling engine automatically generates insights. Everything can be exported in raw data, reports, or processed data. I'll also show a screenshot of the UI. The following are the screenshot. The datasets preview. This is the cleaning panel, the outlier detection, PCA, and regression metrics. This is the plot builders, examples, storytelling panel, and export settings. Deploying to GCP. I deployed the dashboard using Docker and Google Cloud Run. The steps included building a Docker image, authentication with GCP, pushing the image to container registry, and running the deployment. Cloud Run is ideal because it's serverless, auto-scaling, secure, and perfect for dashboards. Final conclusion. To conclude this project shows a complete analytical ecosystems, advanced data processing, visualization, statistical analysis, interactive dashboard, and full deployment on GCP. It enables fast evidence-based insights and scalable real-world usage. This is all for my presentation. Thank you for your time, and you could ask me any questions concerning this presentation, and I'll give you more details on it. Thank you.